that down.
What we're talking about today and what we're covering today is the last section of Chapter 5. We're covering 3.5. We're not going to cover 3.4. Now, 3.5, what we're talking about today is parallel and perpendicular lines. Well, we've been talking about parallel and perpendicular lines this whole week, yes? Now we're mainly going to be talking about the equations of them. Because two lines are parallel if and only if what? Their slopes are the same. Two lines are perpendicular if the product of their slopes is -1. Or the product of the two slopes are the opposite reciprocal. Or their product is -1. So kind of two ways to check it. And that's what we're going to be doing. We're going to first look and determine whether the lines or the slopes of these lines are parallel or perpendicular. Now, the equation for slope is rise over run, or y2 minus y1 over x2 minus x1, the change in y over the change in x. Opposite is the opposite reciprocal. Now, what we're going to do first, in these first two problems, because there's only two of them, we want to determine are the lines and which lines are parallel and which ones are going to be perpendicular. And for me to figure that out, I really need to find I need to find the slopes, because if I can find the slopes of each line, then I can determine which lines are going to be parallel and which ones are going to be perpendicular, yes? So we're going to use this formula here. We can do, let's see, blue. Let's do the blue line first, the slope of the blue line. Well, it's blue on my screen. It's probably just all black lines on your screen, yes? Or on your paper. So when we look at this one here, the 2 points are these two here, -3, 2, and 0, 3. So to find the slope, I'm going to do y2 minus y1 over x2 minus x1. So what would our y value be, our first one? Well, it doesn't really matter. So I heard 2 first. So we can do 2 minus the other one, which is 3. 2 minus 3. It really doesn't matter which one we pick first, which y value we pick. But we got to make sure we pick the y values. So for this here, we have a y value of 2 and a y value of 3. So it doesn't matter which one I pick first. I picked 2 first for this one here. 2 minus 3. Now, since I picked the y value of 2 first, its x value has to go first. So it'd be -3 minus 0. From 2 minus 3 is -1. -3 minus 0 is -3, so we get 1/3. So the slope of line A is 1/3. Would we agree with that one there? Yes? So line A m equals 1/3. I'm just going to make a note of it. I'm going to make a note so we have, this is the slope, yes? Okay, let's do it again, because we have to find the slope of all 4 lines. Okay. Let's look at the red line next. So our two values for the line, this line here, the red one, we have the points 0, -1, and 2, 0. So what are our two y values? Well, the two y values are 0 and -1, yes? So I plug them in. So we can do -1 minus 0. Since I chose -1 first, its y value is, or x value is 0, and the other x value is 2, so we get 0 minus 2. Any questions on this here? We good with this here so far? Refresher of Algebra 1. -1 minus 0 is going to be -1. 0 minus 2 is -2. Well, a negative and a negative make a 1/2. And this is for line B. So line B has a slope of 1/2. Can we say that A and B are parallel to each other? No, they don't have the same slope. Okay. I'm going to erase that there. Line C, down here, the one that's for my screen is green. We're going to find its slope. So what am I going to write on top of this fraction here? What are our two numbers going to be? So we have -5 minus -4 over -1 minus 1. Since -5 went first, its x value has to go first. This is going to be one of the few equations where the x and y values for these points matters, the order matters. Here, a negative and negative make a positive, yes? So -5 plus 4 is -1. -1 minus 1 is -2, and we get 1/2. You all agree with this here? So line C is 1/2. Hey, do we have something that's parallel? Yes. Which two are parallel? B and C. So we would write it as B is parallel to C. And probably it's going to be, I think if we get into a real nitpicky or kind of mathematical definition, it's going to be line. We'll probably want to write line B is parallel to line C if we want to be technical. So we finish with this here. We still need line D. We still need line D. Yes. Now, most likely, based off the picture, it's not going to be parallel to any of these lines, correct? Is the slope of line D going to be positive or negative? Negative, because which direction is it going? Is it going up or down? It's going down, yes, as we go from left to right. So this slope should be negative. Now, our 2 points are what? -2, 0, and -3, 2. So what will we put on top? What are going to be our two values? That would be, so 2 minus 0. And the x value for 2 would be -3 minus, and the other one is -2. At this point here, I think most of y'all know the yellow calculators that we have, or the calculators on your computer will do that there. You can do the fraction, 2 minus 0. You can calculate this all in the calculator. Well, 2 minus 0 is 2. A negative and negative would make a. So -3 plus 2 is -1, which gives us -2, yes? Line dm equals -2. So it's not parallel to any of those, correct? Is it perpendicular to any of them? Opposite reciprocal. Or, so we do have the opposite reciprocal. The other definition, the straight definition of this, is that their products are going to be -1. So we know one of the slopes is 1/2, yes? So if I multiply the slope of D with the slope of B or C, they're the same. Well, let's see what happens. Negative 2 times 1/2 would be negative 2 over, which is negative 2 non-vertical lines are perpendicular if and only if the product of their slope is negative 1. So it is. So what that tells me is that line C is perpendicular to line D. We also have what? That line B is perpendicular to line D. Because since C and B are parallel, and D is perpendicular to C, it also has to be perpendicular to B. Any questions on this here? Any questions on this problem here? Do we need to see another example of finding slopes and comparing them? No, we feel good with this here? Okay. So let's get to the next part of this lesson. Write an equation of a parallel line. So we want to write an equation of a parallel line, a line that is parallel and passes through the point negative 1, 1. So I'm butchering this sentence. Write an equation of a line passing through the point negative 1, 1 that is parallel to the given line. So if it is parallel, these slopes are the what? The same. They're the same. So really, they gave me this equation to tell me what? To tell me the slope, yes? Because, huh? Yeah. The slope will be the same. If the lines are parallel, the slopes will be the same. Yes? Now, do we have an equation that I can use a slope and a point? Almost. There's a better way, because we won't know the value of b, because we don't know what the y-intercept is. But there is an equation called point slope form. Point slope form of a line. Now this equation is y minus y1 equals m times x minus x1. This is point slope form. The x1, y1 is a point, as the values of the x and y of a point. And the m is the slope. So what does this equation have? It has a point and a slope. So I called it point slope form. So looking at this equation is going to make these problems really easier. Because the x and y, so the x and y for this here, that don't have those subnotes, the x1, y1, and the slope, won't change. Because they're just x and y. There are generally input and output, or independent and dependent variables. Now, what was the value of the slope for this here? Because if it's parallel, the slopes are the, and the slope given to us was 2, so the slope of our new line, so this slope is 2, the new slope would be 2 as well. For them to be parallel, the slopes have to be the same, yes? Any questions on this so far? What was the point it went through? What's the point it goes through? Our new line. It passes through negative 1, 1, yes? So the point, since it passes through this, what it's telling us, line's passing through this point. That point is a solution. That point is part of this line that we need. So what's the y value of that point? 1, yes? So I'm going to plug it in for y1. The x value is negative 1, so I plug it in for x1. I plug in the x and y in those corresponding spots. Any questions on this here? solve for y. So the first thing I'm going to, well, a negative and negative make a positive. We can fix that first. Multiply through by 2. Well, 2 times x is 2x. 2 times 1 is plus 2. Yes? Any questions on this so far? We good with everything so far? Well, what do I need to do? There's one last step to get y by itself. Add 1 to both sides. When I add 1 to both sides, I get y is equal to 2x plus 3, yes? And that's our equation. Any questions on this here?
What happened to the negative 3?
So the negative 3 is the y-intercept of that line. So what it's saying is on the graph, our original one is going to cross at negative 3, up 2 over 1, up 1, 2. So that's the original equation, yes? But really, if we're talking about a line being parallel or perpendicular, it means the slopes are what? The same, yes? Does it matter where this line crosses the y-axis? I mean, for this here, we just need the slope, right? Because for them to be parallel, the slopes are the same. The intercepts don't matter. Nothing else about the original function matters. We just need the slope, yes? And that's really all we do, is we take the slope and then trash everything else. Because for them to be the same, I just need the slopes to be the same. If they're perpendicular, we need the opposite reciprocal, and we take that and then move on. We really don't need anything else. And we get this here. Questions on this here? We good with this here? Have y'all done this before? Yes? Have y'all used point slope form before? Yes? Okay. Does anybody need another one of these? Yes? Do another one with finding parallel? Yes? No, we're good? If we're good, we'll move on. But if anybody, even one of y'all needs to see another one of these, I'm going to do it. Let's do one more. Because I think it's been a day since y'all have done this, yes? So, y minus y1 equals m times x minus x1. We need the slope. Did they tell us what the slope is? The slope is? And if it's, hey, it's parallel, so the slopes would be the, so I plugged 3 in for m. So what are our point? What's the point we're going to use? Negative 4, 6, yes? So, what's the y value? The x value is? Well, negative and negative will make a solve for the value of y. Well, the first thing we'll do is distribute the 3. 3 times x will give us 3 times positive 4 will be plus 12. And last but not least, what do we need to do? Add 6 to both sides, which tells us what? Y equals 3x plus 18. And that's it. That's all we need to do for this here. Any questions on this here? How do we feel with finding a line that is parallel?
We don't have that. Did we do it here? No, there's a P and a P. We don't have a.
Okay.
That one's B.
It's B. Yeah, I don't know what happened to A. That's weird. I don't know where that one went. That is strange. 2 whole slides. Oh well. Any questions on finding the equation of a line that is parallel, or finding the equation of the parallel line? Is this problem any different than the one we just did? No, they just gave us a picture of it, yes? So the process will be the exact same for this here. Do we need to see this? Because I have a feeling most of y'all are very feel comfortable with these. Yes? Okay. Find the equation of a line that is perpendicular to the given line for this one here. So we're still going to use the same equation. Y minus y1 equals m times x minus x1. Y minus m x minus. So they gave us the slope, yes? What's the slope?
They just switched around.
Is it positive 2 or negative 2? So the equation of a line where we get slope is y equals mx plus, is y by itself. No, we have to solve this. This is in standard form. If they give us the equation of a line in standard form, we've got to solve it for y. And luckily for us here, this is really going to be one step to get y by itself. We need to do what? We need to subtract 2x from both sides. There's 2x minus 2x will cancel. And that gives us y equals negative 2x plus 2. And really what we're wanting is the negative 2, because that's our slope, yes? So this line, is it parallel or perpendicular? So if 2 lines are perpendicular, their slopes are the opposite reciprocal, yes? So opposite, since it's negative, the slope for our new line would be what? Positive, yes? Because if the slope of the original line is negative, the new slope will be positive, yes? And reciprocal means we flip it. Since 2 is on top, 2 is now going to be on the bottom. But what number goes on top? 1. Because the reciprocal of negative 2 is 1/2. This 2 here is positive.
I thought you were subtracting that.
No, because negative 2x, well, these aren't like terms, so I can't combine them. And since 2 is positive, we write plus 2. Any other questions? Now, if you aren't 100% sure you got the correct slope, what we can always do is we can check it and do negative 2 times 1/2 what we got. Because this would give me negative 2 over 2, which is negative 1, yes? And as we saw a little bit earlier, the product of, if 2 lines are perpendicular, the product of their slopes is what? Negative 1. Because the products of 2 perpendicular lines, their slopes, 2 lines are perpendicular if the product of their slopes is negative 1. So that's a way we can check it. We don't have to do it, but if you want to make sure, you can multiply the slopes together. So any questions on how we got the slope? We good with this here? Now our point is 2, 3. So what value do I plug in on this side? 3. 3 is our y, and 2 is our x. Now we just need to solve. We need to get the value of y by itself. Well, the first thing we can do is distribute, because 1/2 times x is going to give us just 1/2 x. 1/2 times -2 would be negative, what? 1. And then what do we need to do to both sides? We need to add 3. And when we add 3 to both sides, we get 1/2 x plus 2. 1/2 x plus 2. Any questions on this here? Any questions on anything we've done so far? We good with these here? Yes? Now this one here is a little bit nicer. It went on and gave us the slope. So we don't have to manipulate the line at all, but y minus y1 equals m times x minus x1. So what's our original slope? It is positive 2/3, yes? So our new slope would be, it will be negative, because again, perpendicular line, a line that is perpendicular, the slopes are the opposite reciprocals. So since the first one was positive, since this is positive, our new slope will be negative. The reciprocal, we have to flip it. Since it is 2/3 in the original one, our new one is going to be 3/2, because we have to flip it. We have to flip 2/3, which would give us 3/2. Any questions on this here? Let's plug in the point that it passes through, negative 12/6. So the y value would be 6, and the x value would be negative 12. Well, negative negative would make a positive. Y minus 6. Now we have to multiply through by negative 3/2. Well, negative 3/2 times x is just going to be negative 3/2 x. That's not bad. Now we have to do negative 3/2 times 12. Well, negative times a positive would be a negative. 3 times 12 would be 36/2. Any questions on how we got to this point here? Can I simplify 36/2? What would that be? It would be 18. So we have negative 3/2 x minus 18. Last step would be to add 6 to both sides. Negative 18 plus 6 is going to be negative 12. And that's it. That's our equation of the line that is perpendicular. Any questions on any of this here? Any questions on anything we've done? Are you still good with all these here? Yes? Do y'all need to see another example of doing parallel or perpendicular lines, writing these here? We feel good with this here. We feel good about finding slope. We feel good about determining if two lines are parallel or perpendicular. Yes?